Hello student, welcome back to my channel. Today also I am going to discuss very important topic from organic GOC which will be required for everywhere, for every type of competitive exam. It is the base of organic chemistry, which is nothing but a mesomeric effect. What is mesomeric effect? Mesomeric effect is nothing but there is a lot of confusion is there among the student. What is mesomeric effect? What is resonance? There is a little difference is there between the mesomeric effect and the resonance. Now mesomeric effect is nothing but there will be a certain group who will either withdraw or will give the electron to the main structure through delocalization, through resonance, is called as a mesomeric effect. There are two types of mesomeric effect is there. One is called as a plus M and another is called as a minus M. If you look at, there are very easily you can understood this concept. Suppose you look at the bank is giving loan to you. So bank perspective, bank will be plus and you are taking loan, you will be minus. That's why here also who is giving always will be plus, who is taking always will be minus. That's why the which group is giving electron to the main structure of a molecule used to show the plus M effect, and the which group will withdraw the electron from main structure towards itself used to nothing but a minus M effect. So now there are certain group is there like that plus M. Who will show plus M? Like that if you look at, there are certain group like O minus, like NH2, here lone pair is there, like NHR, here lone pair is there, like NR2, here lone pair is there, like OH, like here lone pair is there, here like OR, here lone pair is there of the oxygens. So like NHCOR, like that, here lone pair of nitrogen is there, like OCOR, this lone pair of oxygen also can give electron to the main structure via delocalization. Whereas minus M means, if you look at, there are certain group is there, they can withdraw the electron from the main structure towards itself. So that's why via what? Delocalization or resonance. That means to occur the mesomeric effect, I need a conjugation. What is conjugation? You look at conjugation. What is conjugation? Conjugation is nothing but a alternative double bond, single bond, like this, double bond, single bond, double bond, single bond, double bond, single bond, double bond, single bond. This is called as a what? Conjugation. Whenever this type of group attached with this conjugated system, then only they able to exert this type of effect. So that means delocalizations of electron will happen via resonance. That means if you look at delocalization means what? Electron will not localize to any particular point, it will delocalize over the entire molecule. Whenever there is a delocalization of electron will be there, dispersion of charge will be there. When there is a dispersion of charge, stability will be there. Rather than some electron or electron has a charge, rather than charge is concentrated in a one point, if it is a dispersed over the entire molecule, then there will be the stability of the molecule will be what? Increases. So that is the purpose they will exert this type of phenomena. So now if you look at over here, here there are certain minus M group like a nitro, like a SO2R, like a cyanide, like a CHO, like a CO, like a SO3H, this type of group like a COOH, like a COX, like a COOR. This type of group used to show the which type of effect? So this type of group used to show the minus M effect or minus mesomeric effect. Now you look at how it can operate. Let us look into that one in details. So now if you look at, if there is a, let us take very nice example in a benzene ring. Suppose you look at in a benzene ring, or you take it first straight chain. Suppose I have like this system, CH2 double bond CH, here CH double bond CH, and here you have a nitro group. This is nothing but a nitro group structure. If you look at the structure, how the bonding is happening. Now this is my main structure of a molecule. This is nothing but a main structure of a molecule. Main structure of molecule. And now this nitro group, this is your nitro group. This is which group? nitro group. This nitro group will exert the what effect? Minus M effect. That means through the main structure of the molecule, it will withdraw the electron towards itself via delocalization. Resonance is nothing but what? It's a delocalizations of a pi electron in a parallel p orbital. That is a resonance, nothing else. So now if you look at here, what will happen? Nitro will exert that effect. That means you look at double bond, single bond, double bond, single bond. That means conjugated system is there. Double bond, single bond, double bond, single bond. Conjugated system. In that conjugated system, who is there? Nitro. Nitro can exert what effect? Minus M. That's why what is happening, you look at this pi electron is shipped over here. Immediately electron density in this carbon increases. Then this pi electron will shift over here. Immediately this pi electron will shift over the oxygen. Ultimately, who is taking the electron? In that group who has a more electronegativity, they are concentrating the electron towards himself. Why? Because more electronegative atom has that ability to hold the electrons. So that's why what is happening, they are withdrawing the electron from the main structure towards itself. So that's why here from the main structure, nitro group is withdrawing the electron via delocalization or via resonance, whatever you call it. Resonance is nothing but what? Delocalizations of a pi electron in a parallel p orbital is nothing but a resonance. So here you look at here, the pi electron is nothing but they are delocalized in a parallel p orbital and ultimately who taking by nitro group. So that's why nitro is exerting minus I effect, which is nothing but a withdrawing the electron density to the main structure towards itself via delocalization. That means what is my minus I effect? I can say that withdrawing the electron density, withdrawing the electron density by certain group, withdrawing the electron density by certain group from main structure of molecule, from main structure of molecule towards itself, from main structure of molecule towards itself is called mesomeric effect, negative mesomeric effect or minus M. So now what is the difference between resonance and mesomeric effect? Resonance means only delocalizations of pi electron, only delocalizations of a pi electron in a parallel p orbital. There no group is withdrawing, only delocalization is happening in the pi electron. That is a resonance. But what is mesomeric effect? There will be certain group will be there that is withdrawing the electron from the main structure towards itself via resonance effect or via delocalization. What is resonance? Resonance is the delocalizations of a pi electron in a parallel p orbital. Another video I will give a more explanation on this resonance. You will get that idea also. So now this is nothing but your mesomeric effect minus M. Now same group if it is attached with a benzene ring also conjugated system. If you look at here nitro is like this. You look at with respect to nitro group, single bond, double bond, single bond, double bond, single bond, double bond, single bond, double bond. That means it is also a what? Conjugated system. So now here also what will happen? How to draw this thing, that also you look at, that resonating structure. Now this is first taking electron to this one and this is going. That means first stage what is happening? Two sort is happening. First this pi electron is coming towards the nitro and nitro is giving electron towards the oxygen. First two sorts. And then when withdraw is there is a electron density in the benzene ring will be what? Decreases from the benzene ring towards itself, it is withdrawing. Then what structures we are getting? Here minus and here like this structure plus charge. Now after first stage also there is a only two sort is happening. After that one sort will happen. Here I saw it at a stage, but it will happen in a stepwise manner like that. If you look at first stage this and this, next stage 1 1, So that's why here if you look at first stage there is a 2 sorts, and then next stage what will happen, if you look at here this is going over here, then I will get the another structures. What structures I will get? I will get here there is a plus charge and I will get these resonating structures. If you look at very carefully, I will get these resonating structure. After that again one sort, then what structures we will get? Why I am giving both arrow? Because both the structure is in equilibrium. So that's why I am giving that both directions arrow. So then immediately what I will get? I will get these structures. If you look at here, I will get the plus and this structure. And now here in the last stage also there will be 2 sort. You look at this electron is coming over here and this is coming over here. Then ultimately we are getting like these structures. So we are getting like these structures. If you look at, we are getting like these structures. That means all the pi electron in a benzene ring, they change their positions due to this mesomeric effect. And also, what is the slight difference in between resonance and mesomeric effect? The slight difference is resonance is only delocalizations of a pi electron in a parallel p orbital, whereas mesomeric effect means there will be a certain group, they will either give electron to the main structure or will withdraw from the main structure via delocalization. Based on withdrawing or giving, the name will come either plus m or minus m. Is it clear? So now here the rule I am telling you. First there will be 2 sort positive charge created in a benzene ring ortho to the nitro, and then after that one sort, and in the last there will be 2 sort. Then only you will get the proper resonating structure. This is about the minus m. If you look at the plus m effect, that means there are certain group is there. If you look at, I am taking the help of a benzene ring. Suppose if you look at here attached is a OH like this. So here also attached with a OCH3. This question and this model is very important from the question point of view. Now if you look at, this is a phenol, this is everybody knows very famous structure. This is a phenol and this is nothing but a anisole. This is nothing but a phenyl methyl ether, which is called as a anisole. Now if you look at over here, now oxygen has more electronegativity than carbon. Through the inductive effect, it will take the electron via sigma bond towards itself. So, but through the resonance, it will release the electron towards the benzene ring. So that's why always we need to remember what are the priority order of the effect. Aromaticity is greater than, equivalent resonance is greater than, resonance is greater than, hyperconjugation effect is greater than inductive effect. That means aromaticity is greater than, equivalent resonance is greater than resonance is greater than hyperconjugation effect is greater than inductive effect. So now that's why rather than minus I, in this group which effect will be dominating? Plus R. That's why we used to write down like this, the plus R effect or plus M effect, which is greater than the what? Minus I. So now here the plus M effect, sometimes you will see instead of plus M they can write down the plus R, but there is a slight difference is there in between mesomeric and resonance. Again I am telling, resonance is a delocalization of a pi electron in a parallel p orbital, whereas mesomeric effect means there should be a certain group which will withdraw or will give electron to the main structure via delocalization or via conjugated system. So now if you look at over here, what will happen over here? Now this electron is giving over here like this way. Now you look at conjugated system, single bond, double bond, single bond, double bond, single bond, double bond with respect to the OH. Now what structures we will get? We will get like these structures. What structure? Who is giving plus? Who is taking minus? So OH is giving, that's why oxygen here is a plus, here there will be what? Minus. Here also first time 2 sorts, but here all cases there will be 2 sorts. But in case of a minus M effect, what I explained, in the first stage there will be 2 sort, and then after that single sort. In the last stage there will be again 2 sort in a benzene ring. So now if you look at over here, then immediately what I will get over here, we will get like these structures. So here negative charge, we will get like this structure. So here negative charge. Next stage again 2 sort, you look at you will get 2 sort. So then here we will get like these structures, we will get like this structure here, negative charge, and in the last there will be again 2 sorts, here is coming electron density and here is going. So ultimately the pi electron density in a benzene ring, they change their position and then we are getting the OH like this. Is it clear? There are 5 resonating structures we are getting. You look at including this one, 1, 2, 3, 4, 5 resonating structures we are getting. All are resonating structures. So now, if you look at very carefully, then what we can say over here, due to this Placem effect, electron density in the ortho positions. What is ortho position? This position is called as a ortho with respect to OH. This position is called as a meta. This position is called as a para. This position is called as a meta. This position is called as a ortho. So that means if you look at naming wise, 2 and 6 position is a ortho, 4 position is a para, 3 and 5 position is a meta. Now if you look at over here, whenever there is a Placem effect attached in a benzene ring, electron density always will be more is coming. That means negative charge where there is electron density is more. So where is the negative charge is coming? In ortho and para position electron density is coming. That's why during electrophilic substitutions reaction, electrophile used to attack in ortho and para position, because electrophile means electron seeking thing, electron loving substance. So that's why they are seeking for electron rich position. That's why in a benzene ring, whenever there is any Placem group attached, the electrophile, upcoming electrophile will attack to that place where the electron density will be maximum. Due to this Placem effect, electron density will be more in ortho and para position. That's why whenever OH group attached to the benzene ring, then upcoming electrophile will attack either ortho or para, and then ortho and para product will be there. Both the product will possible based on there is steric repulsion and all those factors, another few factors is there. Based on that, major will be ortho and para, we will determine that one. So now if you look at over here, then we got this idea over here. Now electron is releasing towards the main structure. Who is releasing? OH. That's why OH used to show what effect? Placem effect. But now you look at the OH group is releasing the more electron density to the main structure. That's why OH is giving. That's why OH is Placem is showing. Now benzene ring, in this case if you consider, benzene ring is taking, that's why benzene ring is showing what effect? Minus M. Who is giving? Placem. Who is taking? Minus M. That is the idea. So now this is the idea we are getting over here, Placem and the minus M idea we got it. Now if I ask you one question, in between the OH group and OCH3, which has a, here also it will give you Placem effect, like this phenomena will happen here also. Same way you can do by yourself, the way I draw the resonating structure. But now my question is, which has a more Placem effect, OH group or OCH3? Based on that there will be a questions, there will be idea used to ask. Now you look at here, oxygen attached with a hydrogen atom, whereas here oxygen attached with a carbon atom. Whenever oxygen atoms with a carbon atom, carbon has a more electron negativity compared to the hydrogen. That's why compared to this hydrogen atom, this carbon, there will be slight withdrawal will be there through the sigma bond towards itself. That's why in case of OCH3, releasing power will be little less compared to the OH releasing power. That's why as far as Placem effect is concerned, if you look at, OH will be greater than OCH3. As far as Placem effect is concerned, OH will be greater than OCH3. Why? Because the carbon compared to hydrogen, through little bit withdrawal will be there towards itself more. That's why little releasing capacity of OCH3 will be decreases. That's why as far as Placem is concerned, OH has a more Placem compared to OCH3. So now based on that you get the idea about the Placem effect as well as minus M effect, and you got this idea. Based on that, the benzene ring electron density in different positions will change. Based on that, you can predict the major product during the electrophilic substitutions reactions, and the stability of carbocation, carbon ion, radical, all intermediate you can explain by this important electronic effect, and you can get the major product in a organic. To get this type of more video and more clarity, please subscribe my channel, put your valuable comment so that we can enrich our channel and we can proceed. Thank you very much. Thank you all. See you in the next video.